find the length of the circle of radius 2 given by the parametric equations x equals 2 cosine of t plus 3, y equals 2 sine of t plus 4 for t between 0 and 2 pi. Notice that this is a circle of radius 2 where the center is at 3, 4. Since the circle has radius 2, we know that the circumference or the length of the circle is 2 pi r, which is 4 pi. But let's confirm the formula. In the arc length formula, we would need f prime of t so that we can square it. F prime of t is x prime of t, which is minus 2 sine t. The derivative of 2 cosine t plus 3 is minus 2 sine t. We would also need g prime of t, which is y prime of t. The derivative of 2 sine t is 2 cosine t. We then squared f prime of t and g prime of t and add them up. The square root of f prime of t is minus 2 sine of t squared, and the square root of g prime of t is 2 cosine of t squared. This is 4 sine squared t plus 4 cosine squared of t. We factor out the 4 to get cosine squared of t plus sine squared of t, but this is the trig identity equals 1. So f prime of t squared plus g prime of t squared is 4. The arc length is the integral from alpha to beta, the square root of f prime of t squared plus g prime of t squared, but we found that it was 4 dt. The angle goes from 0 to 2 pi, or t goes from 0 to 2 pi in the parametric equations. Usually, we are given the parameter interval along with the parametric equations, so this third piece of information is important. This is the integral from 0 to 2 pi of 2 dt, which is simply 2 times 2 pi, or 4 pi. So yes, this formula works. The arc length function of t is the integral from t naught to t, the square root of dx du squared plus dy du squared du. Notice that we use u in this case because the upper limit of integration is a variable t already. The speed is the derivative of this arc length with respect to t. Using the fundamental theorem of calculus, we would obtain the square root of dx over dt now squared plus dy over dt squared. So this quantity is also the speed of the particle that travels along the parametric curve.